Hello mathematicians, I'm going to show you how to use your calculator to solve a very common IB AA maths question where we want to find the distance travelled by a particle given some horrendous calculator-based velocity function. And we know in general what we need to do. Well, first off, let's plot the function. So we'll go to the CAS, won't we? Yes, we'll go to the CAS, behave, there we go. I am going to define my function. So v of t is defined as sine t times t squared minus 2t. That's done. And now I'm going to graph that thing. As we go through these, I'll try and show you some little tricks. Now, we defined that as v of t. If I type v of x, that's fine. It kind of knows what we're all about. And we might define that for x being greater than 0. So we'll go control equals there, and we do here x and control equals again for all that magic. X is greater than 0. And we can see our graph. Now let's just copy that and pop it into, where are we? There we go. Let's put that into the whiteboard so we can see what it is we're trying to find. So what we are interested in, get my habit, we want, so you see 1, 2, 3, 4, so that's about there. We want to get this area here, and this area here, but we can't just integrate across the whole thing. We need to take the positive area here and the positive area there. Hopefully you can see that's kind of what we're aiming for. And a sort of traditional way, if we didn't have calculators, we would have to find out where the graph cuts the axis, integrate the first bit, make that negative answer positive, integrate the second bit, that's going to be positive, and the third bit will be negative. We need to make it positive again. But we've got a few tricks up our sleeve for using the CAS. Here's what we can do. Let's go to the CAS. Now I'm going to press tab to get the graph entry screen. I'm going to go back up here, and I might just go put that there just to chop off what we're after. And if I go to the graph entry screen again, I can just plot the absolute value, which is under control divide. No, it's not. Which is under this one here. And we find the absolute value function. So we're doing the absolute value of f1 of x. And you can see what it's done there. It's reflected the whole thing into the positive. And now I can very easily go menu, analyze graph, and it's the integral. We select the graph, so use the trackpad. Rather than trying to use the mouse to get on the lower bound, I'm just going to press 0 and I'm going to press 4. And it's often not entirely clear where the area is, but you can see here we've got 3.82. If you go control click, you can pick up that label and move it somewhere. It'll look something like that. Now suppose we want this a bit more accurately. We can change, I think if we go menu, settings, we can go like float 7 and get a few more decimal places. We can also do this directly in the calculator section. We go shift plus to get the integral sign up. Quick little trick for you there. It's shift minus to get the differential sign. And I go the integral of v of t dt, so I can actually do this without looking at the graph at all if I'm confident, and we get the same thing, 3.81919. So hopefully that little trick should save you some time when finding the area under a graph where we want all of the areas to be positive.